So here we are trying to find out the generators of the cyclic group generated by the elements. So Z7 you can observe it ranges from 0 to 6. Multiplication table I have prepared. You can go through it and you also can prepare it. So what you observe is we do not entertain 0 because 0 is not invertible. Means 0 is not a unit element. So we do not take 0 anywhere in our picture. Only for safe side I have kept it over here. Now, what you observe is, actually I have found it out here. Yes. So you can go with 4. 4 raised to 1, 4. 4 square means 16 divided by 7. We are in Z7, don't forget. So the remainder will be 2. Is it 4 square equal to 2? Then 4 cube. 4 cube means 4 twos are 8 divided by 7. Remainder is 1. So once you get the unity element 1, again the same cycle will repeat. 4 raised to 4 will be 4, 4 raised to 5 will be 2 and so on. So we are not getting our whole set back. I suppose you are following. So 4 cannot be generator. What about 2? If I go with 2, 2 raised to 1 is 2, 2 square is 4, but 2 cube is again 1. I suppose so. Then I go to 3. 3 raised to 1 is 3. Then 3 square, 9 divided by 7, remainder is 2. 3 cube, 27. If you divide by 7, the remainder is 6. 3 raised to 4, 81. When divided by 7, the remainder is 4. Or you can check 6 threes are in our table. What is 6 threes are? 4. I hope you followed me. Then it comes to 3 raised to 5. So 4 5s are 20. 20 divided by 7. 4 5s are we want to check. So 4 5s is 6. Just a minute. 4 5s is a 6. It must be written 6. That is a kind of mistake of mine. Am I wrong? Please check it. What was wrong? That means no one is actually calculating. They're just watching the video. See, I said 3 raised to 4. 3 raised to 4 is what? 81. You divide 81 by 7. What is the remainder? You know 7 11s are 77. So 81 minus 77. What is the remainder?
4.
Yes, that is why I have written 3 raised to 4 means 4. Now to this I need to multiply by 3. So 3 raised to 5. So 4 3s are 12. Now tell me what is the remainder.
5.
It must be 5. So that's why I had written earlier 5 in this place. Is it so? So it must be 5. And if you multiply this 5 by 3 again, because I want 3 raised to 6. So 3 raised to 6 means earlier answer multiplied by 3. 3 5s are 15 and remainder is 1. Followed me? So you can see once I get unity element, I stop. And now I check whether I have got all the elements back or not. So 1, 2, 3, 4, 5, and 6. All the elements are there. Meaning this group is generated by 3. Wait a minute, please. So what you observe here, all the elements are just the powers of 3, meaning this group is generated by 3. Followed me? Okay. Now, if I go to 4, already I have discussed 4. Then I go to 5. 5 raised to 1 is 5. 5 square, 25 when divided by 7. 25 minus 21, you will get 4. Then 5 cube, 4 5 is 20. 20 minus 14, you will get 6. 6 5 is 30. 30 minus 28 will give you 2. What I'm doing? I'm subtracting the multiples of 7. Okay. Then 5 2s are what we do every time, earlier answer multiplied by the base. 5 2s are 10. 10 minus 7 is 3. And 5 3s are 15. Minus 14 will give us 1. So you got all the elements of Z7. Hope so. 1, 2, 3, 4, 5, 6. So 5 is also generator of the group. And for 6, you can watch 6 square itself is 1, so of no use. So it is not a generator. So what is the generator here? Only 3 and 5. So we have marked over here that this group is generated by Z7 star is generated by 3 and 5 also. All right. Hope we got the concept. Sure. Come on.
Yes, ma'am.
Okay. Now I would like to go with the few kinds of papers with you. Yesterday there was a query regarding some papers. So let us handle one by one the concepts that we have up till now covered. Those concepts we have not yet covered, you'll not be able to solve. But here I think there is no problem. How would you find all zeros in Z7? Come on. Anyone? What do you mean by 0? Basically, Z7 is having only 7 elements in it. Now, if I call this particular as f of x, if I label it f of x, then what I need to calculate? F of 0. What will be f of 0? At a glance, you can tell me?
2.
Yes. So it is not a 0. Answer is not 0. So 0 is not a 0 of this Z7. I'll go with 1. F of 1. What will happen? 1 cube is 1 plus 2 plus 2. I get 5. It is again not a 0. Okay. So 0 is not a 0 of this. 1 is also not a 0 of this. I go with 2. 2 cube is 8. 8 divided by 7 gives me 1. I suppose you are getting plus 2 2s are 4. Plus 2 is there. So how much you got? 7, 7 means 0. I suppose you're getting. What this means, this 2 that I have calculated is a 0 of this particular polynomial. Followed? Okay.
Hello, ma'am.
Huh? Yeah.
How to write this as the answer?
Yeah, yeah.
In the similar way only.
Yes, what we'll do is we will tabulate this. Either you tabulate or just every time just go on saying taking x equal to 0, we get f of 0 equal to 2. Therefore 0 is not ZERO. Okay, of f, and where? In Z7. So this is the proper statement of writing. But every time for all the 7 elements, if you go on writing like this, so that might be, so better you tabulate this. Just take the value of x as I showed yesterday. Take the value of x and just calculate f of x over here, and you can write the answer as a combined statement. Did you follow? So what I'll do is I'll write 0 here and I'll show f of 0 is equal to 2. Okay. Then I may start with 1 and f of 1 as 5. And what a thing clicked to my mind was I may have add one more column, and if 0, you can add like this. If 0, here you'll say no. Here again you'll say no. And for a 2, you'll write this as f of 2 equal to 0. And you'll say yes. Will it do? I think this is convenient. Instead of writing the statement 7 times, it's better to tabulate. Followed my point?
Yes, madam.
Okay, okay. So I think this question is clear. All right. Now we will come to this particular B part later. Why, I'll tell you. Then C. Define unit of a ring. So I think the definition is quite known to you, and find all units in Z. So you know better what are the units in Z. Unit means invertible element with respect to multiplication. So you can write this. This answer is already with you. Then it comes Z of I. Show that 5 is not irreducible. So what do you mean by Z of I? Polynomials in I. Z of I means polynomials in I. The way you write polynomial in X, the same way you'll write it. So I would like to myself give this answer to you. I will. Then coming to E. Determine whether the polynomial is irreducible over Q and justify your answer. So this is directly Eisenstein's criteria. You can watch, there is 24. And what are the prime divisors of 24? 2 and 3 only. Do you agree? Prime divisors of 24. What are they? 2 and 3 only. I hope all of you agree with me. Then what I want such a prime factor which does not divide the leading coefficient. So I cannot take 2. 2 is a divisor of 8. So I'll not take 2. I'll think of 3. Now what happens? 3 does not divide the leading coefficient. See, the wording I'm using, I'll straightway say 3 does not divide 8. Or another notation you can write this way, 8 not congruent to 0 mod 3. There are two statements of writing. Either you prefer congruence relation or you say 3 does not divide 8. This line should be very straight, then only it will have some meaning. Or just write in words, 3 does not divide 8. Followed?
Yes, ma'am.
Okay. Then talking of 6 and 9, you can write there 3 divides 6, 3 divides minus 9, 3 divides 24. So what are our requirements is known to you. You can start like this. Only the condition was our leading coefficient must not be divisible by that prime. So that is what we have. Now, one more condition is that 3 square. What is 3 square? 9. Does it divide 24? Can I say like this? 3 square divides 24? Come up.
No.
No, so it does not divide, and the Eisenstein's criteria is fulfilled. What the criteria says, leading coefficient should not be divisible by that prime. All the remaining coefficients must be divisible by that particular prime. And the last, I mean the constant term, should not be divisible by prime square. So all the conditions are satisfied, so it's irreducible. I suppose you followed me. Yes, please respond. Got the thing or not? So you have to mention Eisenstein's criterion there. So please learn the statement, by heart the statement. Okay, learn the statement, give justification, write the statement so that you'll get full marks for that. Okay, now I would like to proceed for the next. Give an example to show that a factor ring of an integral domain may have divisors of 0. So it is to come. We will be discussing this in short while. Then find all prime ideals of Z12. So let me go with the ideals, then I'll clear it to you. So I think there is no question. Going with the next paper, this particular. So the set, I think all of you can read it. The set 0 to 4 under addition and multiplication modulo 6 has unity element. Find it. This question was earlier for 2 marks. So they have given addition and multiplication. When we are talking about unity, what is unity? Can anybody tell me? What is unity?
Ma'am, the multiplicative identity.
Yes, it is the multiplicative identity. So what element is called as multiplicative identity? So the very part, yes, no, it is not usually 1. See, if I multiply A by that element, my A should be safe. I should get back my A. And this should be true for every A. If this happens, then I label this E as unity. I suppose you followed me. So if at all you want identity element, you should actually learn that table. So let us have table for 0 to 4. I have 0 to 4 here. Again, I have 0 to 4 here. And we are talking about multiplication only, because unity is concerned only with multiplication. Because they have asked addition, you will prepare its addition table. I'm just discussing multiplication. Okay. So 0 multiplied to all the elements creates a 0. There is no problem. Okay. What next I want? 2 2s are 4. Never forget where we are. We are in multiplication modulo 6 means we are in Z6. Never forget. Okay. Now, 2 4s are 2. Then I'll go for 4 2s are
2.
2 again. And 4 4s are
4.
yes. So what do you observe? What is the unity element here? Is there any unity? There is no one.
Yes.
So is there any unity you find?
No.
See, unity is that element which keeps your A intact. So if I multiply by 2, 2 is turned into 4 and 4 is turned into 2. So 2 cannot be unity. But if I say to 4, see in our classroom I used to say this row, if you find the same here, then that element is unity. I hope you must remember. I used to say like same row I'm getting here. If I multiply by 4, 0 remains 0, 2 remains 2, 4 remains 4. Whether you go vertically or horizontally, this horizontal line and even the vertical line, same thing is reflected here. So what is the unity element here? 4 is the unity element. Suppose you are getting me. Yes, shall I proceed? Hope you are noting down the things. Either in the form of screenshot or maybe you are taking it down. Of course, I'll be sharing this video to you. Okay, I'll clear the board then. Now, B part you see. Read part B. List all zero divisors in 18, Z18. So the members of Z18 are 18 in number, you know. And the property also, you know, if they are relatively prime. If an element is relatively prime to 18, then it is invertible. And invertible element cannot be zero divisor. That's the basic thing. So you know better 2 into 9. How much? Followed?
0.
Yes, it has to be 0. 3 6 are.
0.
Yes. Anything else is there? Any other element is there which produces a 0?
18 into 1.
18 into 1 is there. Okay. 18, but 18 is not a member actually, Jyoti. 18 will be read as 0, so I can't, yes, I can't take it. Okay, anything else? You can have multiple of 18, 18 to za. So you can say 6 6 za. How much?
0. 36.
Yes, 4 9 za. Still a 0. So I would like you people to list the zeros, zero divisors. Will you? Either say yes or say no.
Yes, ma'am.
Okay. So the hint I have given you. What is my hint? The numbers which are not relatively prime with 18 means those numbers which are having something common factor with 18, they will surely be zero divisors. Okay, so 2, 9, 3, 6, 4, all of them, they are having common factor with 18. So they are all zero divisors. What about 12? Can anybody tell me? Yes. 12 into what is 0?
3.
12
3.
is 3. So this way you'll be searching. Okay. 15. Yes, will you help me for 15? 15 into what will be 0? Shall I give you a clue? See, 18. You just factorize into primes. 3, 3, how much? 2. Factorize 15. 3, 5. Okay. So for 15, you are having already 1, 3. What it is lacking? It lacks in 3 into 2. So 6 5 za. It lacks in 6. So 15 6 za will be what? What is 15 6? Sure?
90.
90 and 90 is divisible by? And we are finding out the LCM of the two numbers. So I think it is quite easy and useful link to you. Even you can go with 14 also. 14 and 18 have 2 in common. So you can go for 14 also. Sure? What is the factorization of 14? 2 sevens. So only common factor of 14 and 18 is 2. So what you need? 9s. 14 9s will work. 14 9s is divisible by 18. Is it divisible by 18? Have to see. Let me divide by 18. This is a rough work. We are not writing in an answer book like this. So what I find? 9 ones are 2s. 2 ones are 2 sevens. What I get? A remainder is, I cannot say equal. I should say remainder is 0. Followed me? Shall I repeat? Okay, I would like to go with 14 back. These things are clear. So let me erase so that you'll come to know because of this. Okay. See, I wanted to talk about 14 and 18. Okay. So what multiple of 14 is divisible by 18? That is my question. So it's but sure that 14 is having 2. 18 is also having 2. What 14 is lacking in? 3 3s are 3 into 3 is not there. So if I multiply by 3 into 3, my purpose is solved. So 14 multiplied by 9. Is it divisible by 18? So that you used to do in schools. 9 ones are, 9 twos are, 2 ones are, 2 sevens are. That is what I have shown here. Quotient is 7. Quotient is 7 and what is the remainder?
0.
Yeah, remainder is 0. That is what I said. So 14 into 9 is congruent to 0. That is what I said. So these are 0 divisors, 14 and 9. What it? We are listing 0 divisors. So every number in Z18 which has some common factor with 18 will be a 0 divisor. Sure? And they are simply asking you to list. And for how many marks? 2 marks. So just you are actually expected to list the thing. Sure? Say yes or say no. Okay. Okay. So let us proceed then. The C part. What C part is asking you? Determine whether the polynomial is irreducible over Z5 or not. How do you determine this? Yes. This is Z5. Z5 means only 5 elements, 0 to 5. How would you do?
4.
So just prepare a chart as last time we did. Values of x, values of f of x, and then your decision whether it is or not. Whether a 0. Whether a 0. And then just go on listing. If it is a 0, that will create a factor. And if it has a factor, then it is reducible. It reduces. If it does not have a factor, we say it is irreducible. So I hope you followed. So I'll try with every. So let me start with 0, 1, 2, 3 and 4. Let me start with 4. 4 square, 16. When divided by 5, I get 1. Plus 4 plus 1. How much? Answer is 1. Followed me? 4 plus 1, 5 is 0. 0 plus 1, I got 1 here. If I go with 3, for 3, what I'll get? Just do it. 3 square is 9. 9 divided by 5 is 4. Plus 3 and plus 1. So 8 divided by 5. Answer is 3 here. So not a 0. If I go with 2, what is going to happen with 2? 2 square is 4 plus 2 plus 1. How much?
2.
Yes. So answer is 2 here. For 1, 1 plus 1 plus 1 directly watch it is 3. And for 0, it is 1. Nowhere I'm finding a 0. F of x becomes non-zero every time. And if it is non-zero means it has no factor. So everywhere I'll be writing no. No. Okay. Okay. So none of this is a 0. Whether a 0 we asked. And none of this is a 0. Means what? It has no linear factor. Means it is irreducible. It is irreducible. Got the answer? Okay. All right. Now I would like to jump to this F. As I saw, this is quite easy. Quickly you can have it because less time is left with us. So I hope all of you are concentrating to this 2z union 3z. 2z union 3z is not a subring of z. Is not a subring of z. How would you go for this? What is 2z? Yes, can anybody tell me? I can say it is twice n, where n belongs to z. And to be very clear, let me picturize it. It becomes singleton, 0, comma, plus minus 2, plus minus 4, plus minus 6, and so on. So all even. Now if I take thrice z, means they are multiples of z, don't say odd. They are multiples of 3. So what are they? 0 plus minus 3 plus minus 6 and so on. So out of this you select 2 and 3. This number and this number I have selected. So 2 plus 3 is 5. Where is 5? Is it here in 2z or do you find it in 3z? It is not a member of 2z, neither it is a member of 3z, means it does not belong to the union. So it is not a subring. So it is not a subring. Followed?
Yes, ma'am.
Okay. So here less than 1 minute time is left, means we'll be out any time. So we won't rejoin today. Okay. So in the evening, we'll be again waiting for the remaining part. So I hope now you have got bit booster. You can go for the papers, question papers. The part that I have covered, I think you'll be able to answer. Please once visit it. Okay, and Uddhav, your difficulties will be talking in the evening. After 4 o'clock, be ready for, just keep alert. Okay.